Study Session 4, Carrying Out Experiments in Psychology. Introduction. No one believes a hypothesis except its originator, but everyone believes an experiment. In this study session, you will learn what experiments are and also explore how experiments are carried out in psychology. Learning outcomes. When you have studied this session, you should be able to 1. Illustrate the two features of an experiment. 2. Highlight the advantages of experiment. 3. Point out reasons why experiments are carried out. Imagine you are a student in a class in environmental psychology and have received the following assignment. Go to the library and defend a table by preventing any other person from sitting down on it for as long as you can. You must use only non-verbal, non-violent means to accomplish this. To carry out this task, you might wait in the library until a table was vacant. Quickly sit down and proceed to spread your books, clothing, and other belongings all over the table in the hope that this disarray might keep others away. After some time, say 15 minutes or so, someone finally does sit down at your table. Ending your assignment, have you performed an experiment? Before answering this question, let us sketch out the major criteria for an experiment. An experiment occurs when the environment is systematically manipulated so that the causal effect of this manipulation on some behavior can be observed. Aspects of the environment that are not of interest and hence not manipulated are held constant so as not to influence the outcome of the experiment. We can then explain that the behavior resulted from the manipulation and also explain two special terms, briefly independent and dependent variables, to describe how the environment is manipulated and how behavior is observed. Basic features of an experiment. Many students, and probably you too, are surprised to discover that the actions described in our library table exercise do not constitute an experiment. All experiments require at least these two special features, the independent and dependent variables just mentioned. The dependent variable is the response measure of an experiment that is dependent on the subject. In this case, the time that elapsed until someone else sits down at the table is the dependent variable or response measure. The independent variable, however, is a manipulation of the environment controlled by the experimenter. In this case, it is the strewing of articles on the table. But an experiment must have at least two values or levels of the environment. These levels may differ in quantitative sense, in brackets, items strewn across only a portion of the table versus items strewn across the entire table. Or, the levels may reflect a quantitative difference. The person defending the table assumes a friendly, inviting expression as opposed to a stern, forbidding expression. The point is that at least two conditions must be compared with each other to determine if the independent variable, in brackets, portion of the table covered or facial expression, produces a change in a behavior or outcome. Sometimes, these two levels might simply be the presence or absence of a manipulation. The library example fails to meet this criterion since it involves only one level of the independent variable. How might we change the procedure to obtain an experiment? The simplest way would be to sit down again this time without scattering anything, then our independent variable would have the necessary two levels: the table with items thrown about and the bare table with no items thrown about. Now we have something to compare with the first condition. This experiment has three possible outcomes. 1. Throwing articles on the table results in a longer time before the table is invaded by another person. 2. The times until evasion is the same, whether or not articles are strewn about. And 3. Scattering articles results in a shorter time. Without the second level of the independent variable, in brackets, the table with no articles thrown about, these three outcomes cannot be formulated. Indeed, it is impossible to say anything about how effective articles are in defending library tables until two levels of the independent variable are tested. When this library experiment is performed properly, the first possible outcome is obtained. A table can be better protected by a person plus assorted articles than by a person alone. We can see then that experiments must have at least independent and dependent variables. Before an experiment can be established, independent variables with at least two levels are necessary. Advantages of experiments. The main advantage of experiments is better control of extraneous variations. In the ideal experiment, no factors (variables) except the one being studied are permitted to influence the outcome. In the jargon of experimental psychology, we say that these other factors are controlled. If, as in the ideal experiment, all factors but one (that's under investigation) are held constant, we can logically conclude that any difference in outcome must be caused by manipulation of that one independent variable. As the levels of independent variable are changed, the resulting differences in the dependent variable can occur only because the independent variable cause has changed. In other words, changes in the independent variable cause the observed changes in the dependent variable. In the library example, we might want to manipulate the facial expression of the person defending the table. 1. To control for extraneous variation, we would need to give careful consideration to other factors that might compromise our ability to make statements about causation. In this case, we might want to hire one assistant to defend the table during the duration of the experiment, or establish objectively that our assistants are, for example, equally attractive. We might also decide to control for gender by either incorporating it as an additional independent variable or by using only female or male researcher assistants. Designing experiments so that there can be only one explanation of the results is at the heart of the experimental method, whereas non-experimental research techniques are limited to statements about description and correlation. Experimental permits statements about causation, that is, independent variable A (facial expression) causes variable B (time elapsed until someone else sits down) to change. In this experiment, we would expect the time elapsed to be shorter when the assistant assumes a friendly rather than a forbidding posture. Thus, in principle, experiments lead to statements about causation. In practice, these statements are not always true. No experiment is 100% successful in eliminating or holding constant all other sources of variation than do other research techniques. 2. Another advantage of experiment is economy. Using the technique of naturalistic observation requires that the scientist wait patiently until the conditions of interest occur. If you live in Trondheim, Norway, near the Arctic Circle, and wanted to study how heat affects aggression, relying on the sun to produce high temperatures would require great patience and a lot of time. The experimenter controls the situation by creating the conditions of interest in brackets various levels of heat in a laboratory setting, thus obtaining data quickly and efficiently. Rationale for conducting experiments. The same general reasons that apply to the conduct of any research also explain why psychologists perform experiments. In basic research, experiments are performed to test theories and to provide the database for explanations of behavior. These kinds of experiments are typically well planned, with the investigator having a clear idea of the anticipated outcome. So-called critical experiments try to pit against each other two theories that make different predictions. One outcome favors theory A, the other theory B. Thus, in principle, the experiment will determine which theory to reject and which to keep. In practice, these critical experiments do not work out so well because supporters of the rejected theory are ingenious in thinking up explanations to discredit the unfavorable interpretation of the experiment. One example of such an explanation is found in a study of how people forget. Two major explanations of forgetting are that 1. Items decay or fade out over time, just the way an incandescent light bulb fades when the electricity is turned off. In bracket, this explanation is called trace decay. Or 2. Items never fade, but because of these, they interfere with each other, causing confusion. For example, War and Norman, 1965, carried out a simple critical experiment in which they varied the time between introduction into memory of successive items, holding the number of items constant. Memory should be worse with longer times, according to trace decay theorists, because there is more time for items to fade out. But because the number of items remains, the theories predict no difference in forgetting. When this experiment is performed, there is no difference in memory. This will seem to nullify the trace decay explanation. The rejoinder by trace decay theorists, however, is that the extra time given between items allows people to rehearse, that is, repeat the items to themselves, which prevents forgetting. Less often, researchers perform an experiment in the absence of a compelling theory, just to see what happens. We can call this a what-if experiment. Students often come up with what-if experiments since these experiments require no knowledge of theory or the existing database and can be formulated on the basis of personal experience and observations. Some scientists frown at what-if experiments. The main objection to them is their inefficiency. If, as is often the case, nothing significant happens in a what-if experiment, say the independent variable has no effect, nothing is gained from the experiment. By contrast, if nothing significant happens in a careful experiment, for which a theory predicts something will happen, the finding of no difference can be useful. We must admit to having tried what-if experiments at one time or another. Most of them did not work, but they were fun. Our advice is to check with your instructor before trying a what-if experiment. He or she probably can give you an estimate of the odds of your coming up with anything, or may even know the results of a similar experience that has already been performed. This brings us to the last major reason for doing experiments in basic research, which is to repeat or replicate a previous finding. A single experiment by itself is far less convincing than a series of related experiments. The simplest replication is the direct repetition of an existing experiment with no change in procedures. Direct replications are especially useful when the original experiment was quite novel. Generally, however, a better way to replicate is to extend the previous procedure by adding something new while retaining something old. Thus, part of the replication is a literal repetition, but the novel part adds to scientific knowledge. This kind of repetition demonstrates the generality of a result by showing how it is (or is not) maintained over different independent variables. Study session summary. In this study session, we have discussed that experiments are performed to test theories, to replicate and expand previous findings, or to show that prior research cannot be confirmed. Only rarely are experiments performed just to see what might happen. Dependent variable is the response measure of an experiment that is dependent on the subject. The independent variable is a manipulation of the environment controlled by the experimenter. Designing experiments ensure that there can be only one explanation of the result, which is at the heart of the experimental method. Experiments are carried out for many reasons, one of which may be for replication purposes. End of study session 4. Thank you for listening.